Okay, so guys, welcome. In every JMC. We'll have at least one question on divisibility. Sometimes they will ask that whether this number is divisible by this number or not. Sometimes they might say that whether this is a multiple of this number or not, which is nothing but same thing. So what we'll do, we'll spend 5 minutes in understanding the basics, and then we'll cover all questions which have appeared on this particular topic, which is divisibility, in last 15 years. We'll go through all of them. So there are 7-8 questions. We'll do all of them. So in this class, we'll cover divisibility. Then we'll have another class. In that, we'll cover remainders, which is also connected to this topic. But today, only divisibility and multiples. So let's go through basics. Okay. So let's check out divisibility rules of some of the numbers. So we'll check out for 1, for 2, for 3, for 4, 5, 6, 7, 8, 9, 10, 11. Okay. For these numbers, we'll see what are divisibility rules. So guys, as far as 1 is concerned, every number, 1 divides every number, right? So we need not check it. Nobody will ask you whether this number can be divided by 1 or not, because yes, all numbers can be divided by 1. Now question is, what about 2? Which numbers are divisible by 2? When your last digit is divisible by 2, if there is a number, check its last digit. If the last digit is divisible by 2, then yes, it's divisible, otherwise not divisible. Okay. What about 4? Last 2 digits. What about 8? Last 3 digits. Okay. So guys, if I have any number, so now let me take some example. So I have got number 3, 4, 7, 8. Whether this is divisible by 2 or not? Yes. Why? Because I'll just look at my last digit, and last digit is divisible by 2, then yes, it is divisible. What about 4? In that case, what I will do, I will check last 2 digits. 78. Is 78 divisible by 4? No, it is not. So if you do 78, you try to divide it by 4, then what happens, guys? We get 2 as a remainder. So 3, 4, 7, 8 is not divisible by 2. Similarly, if you want to check for 8, what we'll do? We'll check last 3 digits of the number, whether they are divisible by 8 or not. So 2, 4, 8, you remember together in your mind, and this is done. Let's move faster. What about 3? Sum of digits. Sum of digits should be divisible by 3. What about 9? Again, same thing. Sum of digits should be divisible by 9. 3 and 9, remember together. For example, if I write a number 52091, whether this is divisible by 3 or not? 5 plus 2 plus 0 plus 9 plus 1. It is how much? 5 plus 2, 7. 7 plus 8, 17. I get 17. So because 17 is not divisible by 3, therefore this number is not divisible by 3. Similarly, I want to check for 9. So 17, I tried by divide by 9. Okay. Then again, it is not divisible because I'm getting a remainder of. So I try to divide by 9, 17, 9, 8 is my 8 is my remainder. Therefore, this number is also not divisible by 9. By the way, if a number is not divisible by 3, it can never be divisible by some multiple of 3. Remember it, guys. If a number is not divisible by 3, it can never be 9. Can it happen that a number is divisible by 9 and it is not divisible by 3? It can never happen, right? Can it happen that a number is, yes, it is divisible by 3, but it is not divisible by 9? Can it happen? Yes, it can happen. For example, let me write some number which is divisible by 3, but which is not divisible by, but which is not divisible by 9. So the number is this. So add 5 plus 2 plus 0 plus 9 plus 4, 13, and 5 plus 2, 7, 7 plus 9. No, I should be taking note 90, but 95. Okay. Now let's sum it up. So I get 5 plus 2, 7, 7 plus 9, 16, 21. So 21 is divisible by 3, yes. Is it divisible by 9? No. Therefore, this number is divisible by 3, but it is not divisible by 9. So guys, 3 and 9 also we have learned. Okay. Now, let's check for 5. Let's check for 5. Uh, when a number is divisible by 5, when its last digit has to be either 0 or 5. Last digit. What about 10? Last digit has to be 0. So simple, guys. 5 and 10 are easiest. The last digit has to be 0 and either 0 or 5 in case of 5. The last digit has to be 0 in case of 10. So it means that all numbers which are divisible by 10, of course, they will be divisible by 5 also. But vice versa is not true. There will be many numbers who are divisible by 5 but who are not divisible by 10. Okay. So guys, we have done 1, 2, 3, 4, 5, 8, 9, 10. Now what about 6? What about 6? So if you want to check divisibility of 6, what do we do? Because 6 is nothing but multiple of 2 into 3. So what I'll do, I will check for 2 and then I'll also check for 3, which I have already learned. Okay. 6, I'll check for 2, check for 3. Okay. Now, what about 7? So 7 we will not learn today, guys. It's not required for your exam. What about 11? Yes, we have to do it. So 11 is slightly tricky one. So what do? We sum up alternate digits, we find their difference, and then we try to find whether it's divisible by 11 or not. So let me let me give an example. For example, my number is 3296182. This is my number. Okay. So what I do, I take alternate digits and sum them. 3, 9, then 1, and then 2. So I sum them up. 3 plus 9 plus 1 plus 2, and this comes out to be 9 plus 3, 12, 13. This comes out to be 15. Then I take other alternate. Other alternate is what? 2, 6, and 8. And I find there sum 2 plus 6 plus 8, and this is 16. Then I do what? I find their difference. So 16 minus 15 is 1. Okay. So guys, a number is divisible by 11 only when this difference is either 0 or some multiple of 11. Either 0 or some multiple of 11. This is how we find. I'll do it. Okay, we'll have some questions also, so I will not do it again. So so guys, how do we write it? It is nothing but we check what? We check difference of sum of alternate digits. Difference of sum of alternate digits will give us 11. So we are done with all the rules. They are pretty simple, and a lot of questions are there in exam based on this. So we'll start going through those questions one by one. But before I do that, I also want to tell you something else. So I have given you rule for 1, 2, 3, 4, 5, 6, 7, 8, and so on. 7 we haven't done. Ignore that. What about a higher number? So whenever we have a higher number, what we can do, we can break it. So if I have to find out divisibility of 15, what I can do, because my 15 is nothing but 5 into 3. So I will check for 5, I will check for 3, and I will see both satisfies or not. Similarly, if number is 24, what I can do, I can check for 8 and 3. I can also check for 6 into 4, my choice. Okay. What if a number is maybe 88? I can check for 11 and 8. Correct? Yes, I can check for I can check for 11 and so this is how we do if they are larger numbers. What about 45? I check for 5, I check for 9, and both should be there. Then only it will be divisible by 45. This is how we do for other numbers. Okay, so we have done whatever basic understanding we needed. Let's straight away now come to the questions. Okay, so this is the first one. Pretty easier one. It came in year 2016 paper of JMC. So let's try this one. Okay, which of the following is false? 12 is a multiple of 2. 12 is a multiple of 2. Yes or no? Yes. Why? Why it's a multiple of 2? Because last digit is multiple of 2, which is nothing but a even number. 1, 2, 3 is a multiple of 3. So how do we check for 3? We sum the digits 1 plus 2 plus 3. So 3 plus 2, 5, 6. We get 6. Is 6 multiple of 3? Yes. Therefore, this number is multiple of 3. Yes, done. Okay. Next one. 1, 2, 3, 4 is a multiple of 4. In case of 4, what do? We check last two digits, 34. I try to divide it by 4 and it is not divisible. So I no. In this case, we have a no. Okay. This is multiple. Then we have what? 1, 2, 3, 4, 5 is a multiple of 5. Of course, yes. Because if you want to check for 5, we just check last digit. If last digit either 0 or 5, it works. Okay. What about this last one? It says 1, 2, 3, 4, 5, 6 is a multiple of 6. So guys, for 6, we have to check for 2 also and for 3 also. So let me check for 2 first, which is easier. That last digit has to be multiple of 2. Yes, it works because last digit is 6. So 2 is okay. What about 3? For 3, I'll check sum of digits. 1 plus 2 plus 3 plus 4 plus 5 plus 6. And what is this sum? This will be 21. And is 21 multiple of 3? Yes, it is. Therefore, because this is multiple of 2 also and 3 also, therefore there will be 6. Therefore, again we have a yes. Okay. So, which of the following statement is so which is a so guys, all of them are true except this one. This is not a multiple of 4. Rest all of them are true. 2016 question done. Very nice. Easy one. Next one. How many of integers are multiple of 3? Again, guys, quite easy one. So I take this one, I sum them up and sum comes out to be 6. Yes, multiple. So I write yes. This is 2 plus 3, 5, 9. Again, yes. This is 3 plus 4, 7 plus 12. Again, yes. This 4 plus 5, 9 and 9 plus 6, 15. Yes, this is also multiple. What about this? This is 18. Yes. So guys, how many of them are multiple of 3? I think all of them are, right? All of them. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So answer should be E because all of them are multiple of 3. Let me also check the answer. Yes, this is correct. All of them are multiple of 3. Okay, great. Okay, next one. Which of the following number is divisible by all the integers from 1 to 10 inclusive? So guys, it looks to be a very longer and tricky question. And maybe sometimes we should skip these questions in the actual exam because there is also time limit. But today idea is to learn. Okay. So in this case, what the examiner is asking us that we have to check for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of them. Okay. So guys, in this case, it's always a better idea to start from a higher number. So we'll start from 10, 9, 8. Why not from 1, 2, 3? Because if a number is divisible by 10, then I need not check for 5. Because every number which is divisible by 10, it will also be divisible by 5. Why? Because 10 is nothing but 5 into 2. Correct? Therefore, if a number is divisible by 10, it will be automatically divisible by 5 also and by 2 also. I need not check for them. Similarly, if a number is divisible by 9, which is nothing but 3 into 3, so I need not check it for 3. Correct? So let's start with the higher number and then see that what happens. Okay. So which of the following is divisible by 10? So what is divisibility? Okay, in that case, because a number is not given, but multiples of two numbers is given. Okay, so we need not actually multiply it. We'll figure out. Okay, so I'll start with 10 and I'll see which of them are divisible by 10. What is divisibility rule for 10? Last digit has to be 0. So in this case, so guys, to have a 0 as last digit, mind it should be multiplication of some multiple of 5 and some multiple of 2. Remember it, right? Only then we'll get a 10. Only that will get a 10. Either we should see a straightaway 0 or we should see some multiple of 5 and some multiple of 2. So in case of A, I don't see any multiple of 5. So A can never be divisible by 10. You can never divide A by 10. So A straight away goes away. What about B? In case of B, I need some 5 and some 2 if I can't see a 0. So I'll get my 5 from here and this is divisible by 2. So I'll get 5 divisibility from here, 2 divisibility from here. Then yes, it is divisible by 10. What about C? 5 from here, 2 from here. Yes. What about D? I don't see a 5. Anyway, I don't see a 0. Otherwise, I straight away written. So not. E, I don't see a 5 anywhere. Done, guys. So in the first go only, we have simplified our question. Now we need not check all the options. Okay. Now we need not check all the options. We have simplified it because our idea is to find the answer and not do everything. So A can never be, D can never be, and E can never be. We just need to check my B and C. With a 10 I have checked. Okay, now let's check for 9. Okay, now let's check for 9. So we have a multiple. Okay, and we want to find out whether this number is divisible by 9 or not. So you can straight away see that in 34 and 45, 45 is divisible by 9, correct? Therefore, this number will be. So we have a number, okay, so we have a number 45, which we know is divisible by 9. Then of course, any multiple of 45 will always be divisible by 9, right? It will always happen. You can try it. Anyway, we learn more when we learn factors and all those things, but you can try it yourself. Similarly, in this case, 45 is there. Therefore, both B and C, will be divisible by 9 as well. Now, because I have checked 10, so it means 2 will also work, 5 will also work, and because I have checked 9, so 3 will anyway will work. Okay. Now, 1 anyway works with all the numbers. Now let's come to next one, which is what? Which is 8. Okay. So guys, if I check this divisibility of 8, 56 I can divide by 8. So I get 7. Then yes, C number will be divisible by 8. What about B? So this is never this number is not even, right? How can it be? How can this number be divisible by 8? Okay. Now this 34, uh, again, this is not, again, I think in this, because now I'm going into more and more into factorization. So at this stage, maybe another idea can be that we straight away multiply them and then we try to find, because sometimes it might happen that there is a number, and let me show you. So if I write 34, okay, into, and I write 20. Okay. Now 34 into 20, I try to divide by 8. So here it is not divisible. Here it is not divisible. But can I say now it is not divisible by 8? No, it will be wrong. It will be wrong, guys. If in fact, if we'll check it, this will be divisible by 8. See, it is perfectly divisible by divisible by 8. Okay. So guys, once again, now uh, because in that case, I think unless we learn factorization, then I can tell you whether how we can check it for 8. But for now, I think straight away what we can do, just multiply both of them, find these numbers, just multiply both of them. Just multiply both of them, find these numbers, and then check for 8. And then check for it. There is another way of checking through factorization, but because we haven't done factorization today, so I will not tell you that method in that class. Okay. So once you will check for 8, you will see that this B is not divisible by 8, but C is, and C will be my answer because straight away I have eliminated all other options. Okay. So guys, once again, let me try to tell you something. Okay. And listen to this thing very carefully. So I have a number. Okay. I have a number A and a number B, and we are trying to multiplying them. I had to check maybe divisibility of maybe 6. Okay. I have to check divisibility of 6. Okay. 6 can be broken into 2 into 3. If one number is divisible by 2, another number is divisible by 3, then yes, this will be divisible by 3, by 6. But if I find that A is not divisible by maybe 2 or 3, B is also not divisible by 2 or 3, then we cannot conclude. So if both of them are divisible by factor, then yes, will be divisible. If both of them are not divisible, then we cannot conclude that it is not divisible. And I give you that example right a few seconds back. Okay, so we have done this one. We have understood divisibility. We had good discussion, and now let's move on to next one. Which of the following is not a multiple of 45? Okay, so guys, for 45, 45 is what? We can check 9 into 5. We can check 9 into 5. So we'll start with easier one. So all of them are a multiple of 5. Why? Because 5, 5, 5, 5 is there as last digit. Now we need to check for 9. For 9, we need to find sum of digit. Sum of digit here will be 7 plus 6, 13 plus 5, 18. Here, again 18. Here, again 18 is sum. Here, again 18. Here, what is sum? 8. So guys, this is divisible by 9. This is by 9. This is divisible by 9. This is divisible by 9. This is not. Therefore, E is my answer. And E is one number which will not be divisible by 45 because it is not divisible by 9. Okay. Now, we come to our 2018 question, and it says, how many pairs of digit P and Q are there so that 5-digit number is a multiple of 15? So now because you have to check for 15. So guys, what do? We'll check for 3 and we'll check for 5. Only then this number will be multiple of 15. Okay, great. So let me write my number. My number is P, 8, 6, 9 and Q. Now always start for easier one. Easier one is what? Checking for 5. For 5, what should happen? My Q should be either 0 or 5. Okay. So the value of Q can be either 0 or value of Q can be either 5. These are two cases. Now I have to think of P. So my number becomes, if this is Q, then my number becomes P 8, 6, 9, 0. Here P 8, 6, 9, 5. These are two cases. Now this number is divisible by 5, but we also have to make it divisible by 3. So to make it 3, I need sum of digit to be 3. So sum of digit will be P plus 8 plus 6 plus 9 plus 0, which is how much? P plus 23. In this case, P plus 8 plus 6 plus 9 plus 5, which is P plus 28. Now guys, these numbers have to be divisible by 3. Okay. So what should we add to 23? I mean, we have to add something to 23, which is P, which has to be a single digit number, so that it becomes multiple of 3. So which is the next multiple of 3 after 23? It is 24. So if I keep my value of P to be 1, it will work, because then P plus 23 will become 24, and yes, divisible by 3. Then what about P is equal to 2? Then it will become 23 plus 2, 25, not divisible. P is equal to 3, again not divisible. P is equal to 4, yes. 23 plus 4 is what? 27, yes, divisible. Then P is equal to 7 will work. Then P is equal to 10 will work, but we can't take P is equal to 10. Why? Because P has to be a single digit number. Okay. So now I'm coming to my answer. So there are 3 values of P. So those 3 are 1, 4, 7, and I will write complete number 8690, 8690, 8690. In this case, what can be my P? So what is the next number? It's 2, P plus 28. Sum of digit has to be divisible by 3. So it is 30. So P value can be 2, P value can be 5, and P value can be 8. You can figure out yourself. So my numbers will be 28695, 58695, and 88695. So how many pairs are there now? Pairs are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And correct answer is option E. Okay. Which of the following is not prime? So guys, again, remember it. You should know all prime numbers from 1 to 100. They're very important for the exam. Just for the sake of remembering, there are 15 prime numbers from 1 to 100. Sorry, 1 to 50. And there are 10 prime numbers between 51 to 100. But guys, you should know all prime numbers which are from 1 to 100, which are 25 in number. Okay. Now, which of the following is not a prime? So again, you have to figure it out, but you can check. How do we check it a larger number? We check eligibility of 3, we check eligibility of 5, we check eligibility of 7, then 11, and so on. So in this case, you can see that this number 1 plus 1 plus 1, sum of digit is 3, therefore it will be divisible by 3. And because it is divisible by a number which is not 1, therefore it is not a prime number, and your answer is E. How many of following numbers are multiple of 11? So guys, for 11, what did we understand? Sum of, so we have to find difference again. Let me, rather than telling you, let me straight away do it. So 187, 156, 253, and 495, 132. These are my numbers. So I add the alternate number. This 1 plus 7 is 8. 1 plus 6, 7. 2 plus 3, 5. 4 plus 5, 9. 1 plus 2, 3. Then other alternate number, here it is 1 only. So it is 8. It is 5. It is 5. It is 9. It is 3. And we have to see their difference. So in this case, difference is 0, difference is 2, difference is 0, difference is 0, difference is 0. What is condition of 11? The condition of 11 is that the difference should be either multiple of 11, or it should be it should be 0. So the one number which is not divisible by 11, which is not multiple of 11, is 156, which is over here, because difference is 2 and not 0. And correct answer is, how many numbers are there now? 1, 2, 3, 4. D is my answer. Okay. Uh, Again, now interesting one, and it's very similar to making some cases and then trying to find the answer. And we'll do this one now. Yes. Hmm. So it says a palindromic number is one which reads same when order of digit is reversed. So guys, what happens in this number? That I write 3, 2, 1, and then I 2, 3. So the you can even if you reverse the number, you will get same number. Okay. If you reverse the number, you will get the same number. This is a palindromic number. Okay. What is difference between largest and smallest 5-digit palindromic number that both are multiple of 45? Of course, is question 24, which is last question. And usually these are tricky one, but it's very good question because we will learn a lot from this question. Okay. Yes. So it is multiple of 45. So what should come to our mind? So 45 can be what? Of course, 45 can be 3 into 15, but we haven't studied divisibility by 15. So what we'll do? We'll use 45 is equal to 5 into 9. So we'll make sure that this number is divisible by 5 also and by 9 also. Okay. It's a 5-digit number, and we have to find largest such 5-digit number and smallest such 5-digit number. This is what has been given to us. Okay. So now, okay. Okay. So let me create a slot. 1, 2, 3, 4, 5. These are my 5-digit. If it has to be multiple of 5, then last digit has to be what? Either 0 or 5. And this number is palindromic number. So if this last digit is 0, the same digit will be over here because it's palindromic. Then it will not, because now if unit, if this digit is 0, it will not remain a 5-digit. It will become a 4-digit number. Therefore, last digit cannot be 0. Question get further simplified. The last digit has to be 5 only. Now we have fixed it. The last digit has to be 5 only. Only then it will be divided by 5. Because last digit is 5 and because it's a palindromic number, first digit will also be 5. Done. Now we also have to find remaining 3 digits in such a way that either it's a smallest number or largest number. So let's try to create largest number first, such that it is also divisible by 9. Okay. So whatever will fill up over here, whatever will fill up in these places, their sum plus 5 plus 5, 10. This total should be divisible by 9. Correct? So it means what is the number which can be added to 10 so that it is divisible by 9? And this number will be nothing but sum of these middle 3 digits. Okay, cool. Now, what is the number which is higher than 10, which is divisible by 9, which is 18? So the value of this sum, can be what? The value of this sum can be 8, because then it will become 18 and it will become divisible by 9. Then it can be, this sum can be 17. This sum can be 26. This sum can be 35 and so on, right? This sum can be only then this total sum with these values, this total sum will become a number which is divisible by 9, and therefore this entire number can be divisible by 9. Okay, so now we know that some of these three digits can be 8, 17, 26 and 35. Now we are trying to create a large number, guys. So how do we create a large number? So a large number will be created when this is 9, correct? 9 is the highest digit, a single digit is available with this. If this is 9, then this also has to be 9. Now 9 plus 9 is 18, and sum can be what? 8, 17, 26 and 35. So I can take only 25, because 18 plus 8, this sum will become equal to 26. Yes, and I get my largest number. So guys, my largest number will be, or you can, yes, 59895. What about smallest number now? Now what do we take here such that number is smallest? What is smallest number? 0. So I'll take 0 over here, and the sum has to be either 8 or 17, 20, 35. It has to be a smallest number. Only 8 will fit in here. So smallest number will be 50805. But you have to find difference of these numbers. So you try to find their difference and it comes out to be 9090. Correct answer is option B, which is the correct answer. Done? Okay. Next one. Amrita needs to select a pin. She decides that it will be made of 4 non-zero digits with the following properties. The first 2 digit and last 2 digit make up a 2-digit number which is multiple of 11. Okay. Second condition is sum of all the digit is a multiple of 11. So guys, what do we do? So we have to create these 4 slots in such a way that whatever we'll put over here, it has to be some multiple of 11. Whatever we'll put here, it has to some multiple of 11. It means what? This number can be 11, 22, 33, 44, 55, and so on. This number has to be 11, 22, 33, 44. And so eventually this number, this entire number will look like this, something like this, right? 4466 or 3322, right? This is how it will look like. So this is the first condition, that first 2 digit and last 2 digit. Then there is another condition. Sum of digits is a multiple of 11. Sum of digit is also a multiple of 11. These 2 conditions are given to us. These 2 conditions are given to us. Okay. Now guys, think it this way. Whatever value I'll put here, maybe this value is A, this will be A, and something here which is B, it is also B. And now you can take any digits. Okay. Now, if you'll add them up, so A plus B will be what? So anyway, you can take examples if you are not comfortable with doing A and B. Idea is this sum will always be an even number. This sum will always be an even number. Now, but second condition says the sum has to be a multiple of 11. Therefore, my overall sum can be 22. It cannot be 11. It can be 22. It can be 44. It can be 66. It can be 88. It can be 1110 and so on. Correct? These can be the sum of all the digits, guys. Now it can be the sum of all the digits. Now these 4 slots are to fill 1, 1, 1, 1. Okay, and I told you A, B, B, which is nothing but 2. A plus B is the sum. So if this value is equal to 22, right? It means what? That my A plus B will be what? Equal to 11. I get this much. Can it be 44? It can't be. Why? Because if I do 2, A plus B equal to 44, then A plus B will be 22. Now there cannot be any 2 digits. There cannot be any 2 single digit number which will add up and make 22, right? Therefore, this 44, 66, 88, 1110 anyway goes away, and my condition is now only that A plus B can be 11 only. So now I have reduced my question to that. Now my question is reduced to sum of digit has to be 22 and A plus B is 11. Now if I have to make 11, then what can be values of A and B? Value of A can be 2 and 9 because they are single digit number. I cannot have 1 and 10. 3 and 6. 4 and 5, right? Then 5 and 4 and 5 and 4. Then value of A can be, let me take more values, 5 and 4, then 6 and 3 and 9 and 2. Okay. So guys, based on this, you can put up these numbers and your number will come out to be something like, it will become 2299. Then of course, 2299, then 336644555544, then 3366 and 2, no, sorry, 6633 and 9922. You will get 6 numbers, and therefore correct answer will be option. How many numbers are there? Oh, I missed something. Oh, sorry guys, sorry. I did this. A plus B has to be 11. So this can be 29, 38, 47, 56, 65, 74, 83 and 92. Now you can put up these values 1, 2, 3, 4, 5, 6, 7, 8, and correct answer will be option D. Option D will be the correct answer. Okay. So that's all for today, and thank you so much. All the best.